Hey, so today we're going to talk about motion, and motion is a change in position. So that change can be a great change or a small change, but any change in position is going to be motion. There's a couple of things we're going to talk about with motion, and it's speed and velocity. And while they're similar, they're not exactly the same. Within speed, we have instantaneous speed, which is a measure of how fast something is going at any instant or any given moment or any snapshot in time. When you have a radar gun that either measures a pitch, maybe in a baseball game, or perhaps measures your speed if the policeman is trying to catch you speeding, or sometimes you'll see the signs that have the radar sensor in it as you're driving down the street, and it will tell you how fast you're going. That is a measure of instantaneous speed. It is how fast you're traveling at that given instant. The second thing, and again, radar guns, speedometers. The second speed is average speed, and that's the one that you actually calculate, taking the total distance traveled over the total time that you travel. And that's really more or less when you say, it takes me 3 hours to get to a certain location, then you are really calculating how fast you can go on the interstate and how many miles it is. So for this one, it's distance traveled and the time that it takes for the trip. And then the formula is speed equals distance over time. And if you notice, we have this speed triangle right here where we put D on the top and speed and time on the bottom. And then, of course, if we're looking for speed, it's distance over time. If we're looking for time, it's going to be distance over speed. And if we're looking for distance, it's speed times or multiplied by the time that it takes. And that's how we use that triangle. Now notice that we're talking about speed, so we're going 65 miles an hour. It doesn't matter if we're going north, south, east, or west because we're just talking about the speed. And again, distance over time. So here's an example. We said we traveled 150 miles and we went in 3 hours. So we'll take distance over time and we'll find out that we traveled 50 miles per hour. So examples for units may be miles per hour. MPH would also be miles per hour, meters per second, kilometers per hour, depending on what you have for your actual units. Now, as I said, speed is just magnitude. It is just talking about how fast you're going or the distance that you're going. It does not indicate whether or not you're going left, right, north, or south. So examples of scalar measurements are distance, 10 meters, doesn't say which way. Speed, 60 miles per hour, again, doesn't say in which direction. And time, which is 5 seconds. Again, these are all scalar measurements. They only give you an indication of magnitude. They don't give you an indication of direction. Displacement, however, is a vector measurement, okay? So a vector measurement tells you direction, and displacement in particular is a measurement of how far an object is from where it started and in what direction. So displacement would be 2 meters left, whereas your distance would be 2 meters. Your displacement would be 2 meters left or 2 meters west, whichever. Here's a good illustration of the difference between displacement and distance. Distance would be the total amount that you traveled. So if you notice the distance from A to B along the blue path is not a direct path. Displacement, however, is the most direct route. It is the distance between A and B and in what direction, okay? So it's from beginning point to end point, not the path that's traveled. Distance is the path that's traveled. Displacement is from A to B, or as the crow flies, as someone might say. So if you look at this particular situation, we're going to look at displacement in this form of a hypotenuse, if you will. It's going to be a triangle. So if you say that Dad and his 2 children left the oak tree and they went 4 miles east, and then they went 4 meters east, and then 3 meters north, that would be the distance that they traveled, which would be 7 meters. But their displacement from where they started at the oak tree to where they ended at their house would actually be 5 meters. And again, those of us that are in geometry recognize that as a right triangle. A squared plus b squared equals c squared would be how we would figure out that measurement. Again, displacement being a vector measurement, so it has to have direction. Magnitude, when we say magnitude, that would mean like size. The magnitude would only mean like 7 meters, right? It wouldn't give us the direction. This displacement is the from start to finish, so it would be 5 meters. And then in this particular situation, it would be northeast. Okay. Now you might notice this right here as your compass rose, or it's going to give you north, south, east, west, or how about never eat soggy waffles, right? So that you can remember that. And again, this is what we're going to need to use when we talk about vector measurements, because vector measurements, again, have size or magnitude and direction. So 29 miles per hour north. Now, velocity, remember we talked about at the very beginning, we're going to discuss and calculate speed and velocity. Velocity is similar to speed. It has the same magnitude as speed, but velocity is a vector measurement, so therefore it's got direction as well. So we can have negative velocity because we would be moving in a negative direction more so. And for speed, we can't have a negative speed because speed is only the magnitude. It's only size, and so velocity is size and direction. So if we're moving forward at 50 miles per hour, our velocity would be positive 50 miles per hour. If we're moving backwards at 50 miles per hour, we are negative 50 miles per hour. That's not negative in the sense of slowing down. It's negative in the sense of the negative direction. Velocity also deals with the displacement of the object, okay? Not only where did you start, but where did you end? And again, velocity is a vector measurement. Okay, now let's talk about using signs. If we say this is the y-axis and this is the x-axis, we know that this is positive here and here, and this is negative here and here. So we have the positive quadrant, right? The negative positive quadrant, negative quadrant, positive quadrant, okay? So we'll need to use those signs when we're given vectors or direction. Okay, so north would be positive, right? South would be negative, and then right and left would be positive. So this would be north, south, and this would be east and west. And that was how we would get our positive and negatives in the sense of vectors. Okay, so that's just kind of the introduction of motion, speed, and displacement. Today we're going to calculate some speed with some word problems, and then we'll talk tomorrow about displacement.